Viscous drag is the frictional force between an object and a fluid which opposes the motion between the object and the fluid. This drag force is often from air resistance and can be expressed by Fd is equal to 6 pi nRV, where Fd is the drag force in newtons, N is the fluid viscosity in newtons seconds per square meter, R is in meters, and V is the velocity in meters per second. Let's look at an example to get a better understanding. A stone sphere with a volume 500 meters cubed falls through air and experiences a drag force of 30 newtons at a particular instant. Air has a viscosity of 0.0000181 newton seconds per square meter. Calculate the speed of the stone at that instant. First, we're going to want to list out the known quantities, so we have V, which is 500 meters cubed. We have the drag force, Fd, which is 30 newtons, and we have the viscosity of air, which is 0.0000181 newtons seconds per square meter. The viscous drag formula is Fd is equal to 6 pi nRV, and we're still missing R in this case, and we can find R by using the volume of a sphere, which has the formula V is equal to 4 over 3 pi radius cubed, and we can rearrange for the radius, so it would be R. Now we can plug in all of our values, which gives us 1,178.1 meters. Now we can plug everything into the formula and rearrange for V. Which gives us 74.64 meters per second.